we've already addressed exponential growth and decay. We've been looking at the graphs and the tables. Okay, and been given an equation to do that. Now we're going to apply that with word problems. Okay, this is the formula that we're going to use for growth and decay. And the key thing that I need you to recognize, if it's growth, you should see some type of addition. Guys, look at this. If it's growth, you should see sometimes some type of addition, which means your decimal or your number will be greater than 1. Okay? Because we're adding to 1, this will end up being greater than 1 when it's all said and done. Now, for decay, we're subtracting. So that means our rate would be less than 1, but greater than 0. So if I see words like increasing, we're going to add in the parentheses, versus decreasing, we're subtracting. Okay? All right, so we're going to start with growth first. So if you open up the tab, you need to know the parts to the formula. Open up your growth side, and inside we have the function of x equals a parentheses 1 plus r, close the parentheses, to a power t. So the first part is the a. That a, add this to your box. That a represents the initial amount in the word problem. Your starting amount. A equals initial amount, starting amount. The a is always what will be multiplied to our rate, or it's what's always in front of the parentheses. Okay. The other part in the formula is this r. This r represents the growth rate or your decay rate, depending on the type of word problem. Now, here's the key thing. It is a percent that you change to a decimal. The r, your rate, is always given as a percent, but you have to change it to a decimal when you put it into the formula. And then the t, that represents time. The t, the exponent t, is your time. So in our first example, they have given us the exponential function below that models the amount of Jose's savings account. It says right here where x represents the number of years since he invested the money. So remember, f of x equals 3,000 times, because I see this times right here, this would be my a, then my parentheses, 1 plus r to a power t. So I need you to understand that 3,000 is the a, the initial amount. And notice here, the 1.06, remember, if it's greater than 1, it's a growth. If it's less than 1, it's decay. So the 3,000 represents the initial amount. And to find the growth rate, okay, meaning the r, the growth rate is your r. To find that, I have to take this base that the exponent's with, the exponent of x. And so our growth rate has the formula 1 plus r equals 1.06, that base. And we're just going to solve for r. To do that, you're going to have to just subtract 1. So the r, the rate, is 0.06. But we have to change that to a decimal. 0.06 is equal to what percent? Yeah, 6%. We have to change to percent. to do that, all you have to do is multiply by 100. Okay, so you take the decimal, which was at 0.06, and you say times 100. And that's what gave you 6, which was 6%. Okay. All right, so now we're going to be given word problems and apply the formula to find our new amount. All right, does anyone still need example 1 here? All right, so we're going to go to example 2. All right, here's our scenario. The cost of tuition at a state college is $8,500. It's increasing by 3% each year. What is the cost of tuition after 6 years? What's our key information here that we can use? What do you think is important? 3% is very important. That's our rate. 8,500. Yeah, 8,500. Okay. So the A initial amount is the 8,500. The rate is our percent, which is 3%. But we cannot just write 3. We have to change that to a decimal. Oops, sorry. So what decimal would that be? Yeah, 0.03. Okay, to change it, just divide by 100. Okay, and then our T, our time, is 6 years. Okay, so what we're doing is we're putting this information into our formula. Remember, our formula was A parentheses 1 plus R to the power of T. So I'm just substituting each part. A, our initial amount, is the 8,500. Then I'm going to do 1 plus our 0.03. And our time, we're going to raise it to a power of 6. Okay. Now, you can simplify this if you want to. Or you can just, because the beauty of our calculator is it could do that. But if you simplify this, I'm just going to write simplify. Then our equation is still going to be 8,500, but now it's going to be 1.03 to the 6th power. Okay, it's the same thing. You don't have to simplify it. I would just type it in, like do the substitution. So make sure you have a calculator in hand. Okay, so what you have to do is, let me clear my screen out. You start off with the 8,500. Then you can do your parentheses. 1 plus our rate, which was our 0.03. Close the parentheses and raise it to a power of 6. And then you're going to hit enter. Remember, we're talking about costs, tuition costs. So we're talking about money. So what am I writing as my answer here? Talking about money. What's the cost after 6 years? 10,000. Yep. 44 cents. It is $10,149.44. No, it's at 45 because there's another 4 here, and that wouldn't round the cent up. It has to be 5 or more in the thousands place right here. Okay. All right. So read the word problem, get the key information, and then we're going to plug it into the formula. So let's look at example 3. When y'all ready, let's go ahead and put in example 3. What's our key information on example 3? Yep, the 10,000. 4.7% interest and 5 years. Okay, so what represents our A, the initial amount? The 10,000. Good job. Okay. Then we need our rate, our R. What is that? Okay, 4.7%, but we have to change that to a decimal. Yeah, hold up, yeah. It's so to change it to a decimal, guys, you just take and you divide it by 100. So like if I go to 4.7 on the calculator and divide it by 100, there's the decimal. It's equivalency, okay? All right, so we got our decimal, which is 0.047, and then we need the time, our t, 5. Okay, so we're taking this, we're just going to plug it into the parts, okay? 10,000, parentheses, 1 plus our 0.047, close the parentheses, to the power of 5. And this is money as well. So in this one, we're looking at $12,581.53. Okay. Because after the 2 is an 8. So this, to the nearest cent, we would round up here. No, I said 100. It's 581. Sorry. All right. So the only difference we're going to address for decay versus growth is that in the formula you have subtraction. So your A is still your initial amount. Okay, A is still the initial amount. The R is still the rate, but it's percent change to a decimal. And right here, that's the biggest difference. It's the subtraction versus addition. And your T is still time. So get the parts down, they're not changing. So we have on our example 4 here, we have again an exponential function that models Melissa's cars, where X represents the number of years since she purchased the car. The 2,800 represents the A, which is the initial amount. Because that initial amount is getting multiplied by this base, and if you look at that, the minute I see that it's less than 1, I know it's going to be a decay. And to get a rate of decay, your R, that part of the formula is 1 minus R. So our 1 minus R is going to equal to that decimal 0.86. So to calculate the rate, we're going to have to solve for R by subtracting 1. When I do, I'm left with the negative R equals, where are we going to get here? When you subtract the 1 from the decimal, 0.86. Yeah, negative 0.14. We can't have a negative R, so you're going to divide by negative 1. which means our rate, yep, 0.14. So what percent is that? Yeah, 14%. You still have to give the rate as a percent. All right. All right, so now we're going to be given the word problem, and we're going to take the parts, the initial amount, the rate, and the time to find our new value. So if you look at now at example 5 here, we're talking about student population at a school is 1,375. Right here, the keyword is it's decreasing by 2%. Decreasing is indicating decay. It says, what is the student population after 7 years? So our initial amount is the 1375. The rate is 2%, which is 0.02. And our time is 7 years. So because we're doing decay, because it's decreasing, is the decay part. So when I plug it in, my 1375 is going to be parentheses 1 minus my 0.02 to the power of 7. So we need to type that in, but we're talking about population, so now we have to round to a whole person when we calculate our new population. So start off with the 1375, do your parentheses, 1 minus our decimal, close the parentheses, and raise it to a power of 7. What's our new population? Yeah, 1,194. Okay, because we have 0.6, we got to round that up for a whole person. All right, I want you to try example 6 if you haven't already. I'm going to come around and stamp check. This is the next item that's going to go in your spiral. After the last 2 things we did was our blue foldable over exponential functions with some examples, extra examples. So it's blue, white, and then it's going to be purple. Yes, I'm coming. Okay, if you plugged everything in, most of you had this, you would have got 306 animals left. Okay. So what you have next is this worksheet over exponential growth and decay with word problems. It is a 2-page document. Just a reminder, your growth is the following formula. Y equals A parentheses 1 plus R, close the parentheses, raised to the power of T. For exponential decay, this is the only difference with decay is now you're doing subtraction inside the parentheses. So you might want to copy these 2 formulas down because that's what you're going to be using with each word problem. Now, you do have to pay attention in your reading for clues indicating growth, which would be increasing, versus decay, which would be decreasing or depreciating. Okay. All right, so if I look at, I'm just going to go over a couple, and then you'll have time to either to work on this or to finish the homework or the decimals if you still haven't done that. So we have annual sales of a fast food restaurant, basically starting right here. This is our initial amount of the 650,000. It says also we're increasing is the key at a rate of 4% per year. They want to know what is our annual sales after 7 years. So A, your initial amount is the 6,500,000. Your rate is 4%, but we need that as a decimal. Remember, just divide it by 100, that gives you the decimal. 0.04, if we're struggling doing it mentally. And then your time, your T, is 7 years here. So we're just plugging it in. Use your calculator, do your calculations. We're talking about money, so you have to round to the nearest cent to a power of 7. So I want you to definitely substitute the part, show me your setup, write out the equation, then go to your calculator, type in our values, our initial amount, and increasing. So this is 1 plus 0 point, what was our rate? I forgot. 4%, okay. 0.04, close the parentheses, raise it to a power of 7. So we get 100,355 and 66 cents. Okay. So make sure we're rounding correctly with dealing with money, versus if it's talking about population or a certain species, that's a whole number. Now on number 2, because I see we have a population of 2,500, but because we say decreasing, that's going to be decay. So we want the population after 5 years. So this would be 2,500. 1 minus our rate, 3% as a decimal, is 0.035. And now we're raising it to a power of 5, because we want the population after 5 years. So please show your setup, guys, at least your equation. And then, yes, use your calculator to do the computation. But at this time, guys, if you still have not finished this homework sheet from 2 nights ago, this is priority 1. You need to do this homework, because I know you needed your calculator to complete the table and to sketch your graphs, and then some more tables and matching of graphs. That should be in the tray if you did not turn it in yesterday. Otherwise, it's going to be late. And then after you finish, if you're done with this, we are working on our worksheet, our current worksheet, homework 2, I think it is, homework 8, excuse me, or you're working on your decimals if you didn't finish that yesterday. Okay? Yeah.